Okay, so we are at April 1st, 2024. We've got data science here. Everyone knows how I am with time because I want to be respectful of the people who showed up here on time. And so I'm going to point it over here because I've got a couple things going on here. I've got a little introduction. We're going to talk about data quality today. So you can see what we've got for data quality. I've got week 10, I've got our zip files, I've got the exercise that we're gonna do. We're gonna do something related to data quality, and it's gonna harken back to a project I did almost 10 years ago with the NCDOT, where I got my, literally my first big grant. And a lot of times, whether it's jobs or grants or whatever, and you apply for these things, you get a whole lot of no's. Like we don't like you, no, 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 and eventually you start getting yeses, and you have these points here where someone believes in you, because a lot of times when you file for a grant or you file for a job, what's the biggest reason why you don't get a job? We don't have enough experience. Well, give me the job and I'll get experience, and it's this it's a perpetual circle. The same thing with grants. You don't have any prior experience, so how do we know you're going to do the grant? Well, just give me the grant and I'll do it, and it's tough. We run into these problems, and so at some point in time, someone needs to give you a break. And this group gave me a break, and I had this summer project, taught me a lot about kind of management and all those other things. And really, the biggest rule with land management to me is finding responsible people that can take off on things here. You guys know me. I'm in charge of a lot of different projects here. I can't be the expert at everything here. And so if you surround yourself with good people and good projects, good people who know what they're doing, then you've done three quarters of your job. So I'm going to start sounding like my parents or whatever. So, but we got exercise number 8. We're going to talk about the NCDOT data quality download, because we're going to run some data cleaning. We're going to talk about data quality, what entails data quality, because this kind of gets back to my beginnings of GIS. This gets into my skill set of GIS, because a lot of times when we start working with data, these projects, where do you get the data from? I give it to you and here it is, and do we really wonder if it's any good? Now, some of the data that you download from the NCDOT website, or people were looking at SNAP benefits and all that other stuff, it might not be really good. It's got things like margins of error attached to those things like spending patterns, especially when we have really small sample sizes. They could be very, very variable, no pun intended, in size. And so we need to kind of really think critically and holistically about data quality. In particular, we're going to look at Python programming solutions to address that for really large databases, where we could do it a little bit more elegantly using Python, as opposed to find and replace and select and all these other things which you can kind of do. Because when you go to a job, at some point in time, you're going to say, hey, look at this little Python program I wrote to go through and check the integrity of data here, which is a lot better than you pointing and clicking and doing all this other good stuff here. So I don't want to get kind of too far, too much into that there. But we're going to talk about data quality here. And the idea for this came from a project that I had in 2014 from the NCDOT. NCDOT is the North Carolina Department of Transportation, and every year they have these grants they give out. They have these grants they give out. I think they're published in September or something like that. And they had one where they wanted to go through and map the actual data quality of all the NCDOT GIS data. And so this is where the NCDOT GIS data exists. You can go and download these things here. I'll explain these a little bit, because once you kind of get into the weeds with something, like I've said before, I'm kind of a jack of all trades. I know a little bit about a lot of stuff, but once you start working for an organization like NCDOT, this is what you do 40 hours a week. It's not what you do just for project. You do this for a living. And so it's really, I think people become kind of intimately familiar with these data and all the nuances of these instead of just this 1 week in and out where we look at these. And so there's a lot of neat data resources out there for the NCDOT. Another thing they collect is AADT, average annual daily traffic. So there's places around where they have the daily traffic where you can maybe start to associate things like air quality with traffic. There's probably about 6 places around campus that they say, hey, 20,000 cars a day drive over here, little like rubber strips that go across the road that keep track of those. And these days they probably have like light or something like that, detectors. So these are some of the data layers that we can go and download. We've got road data. We have the actual roads right here, and then we have road characteristics. This road characteristics, and this is what we're going to look at today. There's more than 1 million of these records right here. And you can do this in ArcGIS Pro, but we can download this thing. And basically, as you drive along a road, when one of the characteristics of the road, like speed limit changes, it becomes a new line segment. So there's like 1 million of these throughout the state. So even though it's like Route 40 or Route 751 or whatever we have right here, when the characteristics, it goes from 1 lane to 2 lanes. And there's about 90 different road characteristics. And this was part of the grant that we had because there's a lot of kind of ideas of data quality. And we'll mention a couple here. But data quality can be, if you look at it and it actually doesn't line up with where it's supposed to be, well, that's horizontal accuracy. If we click on it, it doesn't have the right information. That's data quality. If we click on it, it's just got a bunch of nulls there. That's data quality. And so we did this project about 10 years ago where we went and figured out what's the data quality, and we mapped data quality on a county by county basis. And so I put together, and I had been at Central for about 3 years, and I had, I keep applying for all these grants, getting a lot of no's. And I finally got this one from a guy named Jonathan, who is an engineer over at NCDOT. And this is a 1-year project because we actually had to go and line up the imagery with existing imagery, line up the data and how far off was it. So a lot of this was kind of some manual checking. Other was some Python solutions. So we kind of thought of some creative ways to do this. But this was about $75,000. $75,000 is pretty good, for us. But these days, like these NASA grants and things that we got, Dr. V just got one for like $2.1 million. So like 30 times 7 million, $75,000. So, so these keep kind of building up on each other here. But some of the things about data quality basically mean like how far off is this thing? You can see it's in the middle of the road, but is the actual imagery off too? When you go and take a drone image, and I'll speak specifically to drone because we got a drone management class, but how good is the drone imagery? Is it correct?
It can be.
It can be.
It can be very precise as long as it's set up properly, like with its GPS and as the internal GPS is looking, and then your pictures stay relatively consistent in terms of height and where you're taking them, so you can properly measure and map it. It can be great, but it can very easily fall apart.
Yes.
Once too many factors are.
Yes. And one of the reasons for that is we were doing this the other day, and there was a whole bunch of imagery that was like moved up 20 feet. I think Barron was working on it because like the GPS was like off when we were collecting imagery. So it moved it up or moved it over or whatever. So this is kind of a multi-tiered process where that even though we're comparing it to imagery, the imagery might be off. So it might be an aggregation of errors here. And so this is kind of what we did here. This is our research team. We've got some students here. The guy in the upper right, he was a grad student here. This is his son. The one in the middle is Edward. He works, he got an NCDOT internship or fellowship fellowship, and I think he's working for a contractor like Pike, and the one in the upper left, he worked for Pike for a while, and now he's working over in the photogrammetry unit at NCDOT. So these are all students who kind of got jobs at NCDOT. But some of the things that we were looking to measure, when we look at the imagery versus the arc, we could see it's off. So we had people go and actually measure it and average it up. But some of the other things we started to look at were things like attribute accuracy, attribute completeness, because who wants to go and check to count how many times something is null? And we already ran a little Python that did that. We already said, hey, how many, didn't we run a null value checker already? We created this null value checker. How many times is it null? And that's what we're going to do. We're just going to build on that today. So we wrote this report here. We have the results here. We looked at horizontal accuracy, attribute accuracy. So there were some of the attributes they wanted to check. So when we really get into the weeds, we want to make sure, hey, there's something for street name. Is it on a military base? What is the, the width of these things? And so we get it, when you start doing these things for a living, it gets really ugly really quickly, and it gets really understandable. Now, I got a lot of numbers here, and I don't want to say no one cares about this stuff, but I went out in the field. I created a little field app right here. Attribute completeness, but what do we want to look at? Let's just go look at the maps. Okay, cool. And you can see, or sideways, you can see where the data is the best, because basically what we wanted to do is, where should NCDOT dedicate resources to update their data? That was the big thing. And so you can see how far off it was when it comes to accuracy, highway divisions we had here. We're going to be looking at highway divisions here. Just the different components of accuracy, and then the different attributes, which were correct, incorrect, or whatever. But I've posted it up there, so if you have trouble getting to sleep, feel more than free to open this thing up, and it'll put you to sleep really quickly. But I liked it because it was a neat project, and down at the bottom, I've got all my Python code that I wrote in support of this. I don't write a lot of this stuff by hand. When we measure things, I put in some things right here, but this is all the Python code that we put there to run some of these different programs, to run this null value checker to see if it's complete. Hey, when we run this, and NCDOT said, hey, you better have a speed limit in there. If a speed limit is there, you figure out how to put one in there. So we're going to be replicating a project today that we did with the NCDOT. You better have a speed limit in there, or they would just, or they'll go back to their contractors and say, hey, these are the places where speed limits were off or incorrect or whatever. So I like this project here. I like the idea of this here. I also put some verbiage up here about data quality parameters. And so to me, reads data quality. And this is specific to GIS data. So I put some verbiage up there because today I'm going to talk about a little bit about data quality, because a lot of times when we look at data quality, I think a lot of people just kind of gloss over, here's the data, let me start working with, and then at some point in time, some jerk like me in the back is going to say, well, where'd you get the data from? When did you create it? What years is it from? If you're working with data from 2000 to 2021, well, that stuff's going to change. Why don't you look at 2010 or whatever? And so a lot of times we use the term GIGO, garbage in, garbage out, because just because it's in the computer or Mulrooney gave it to you doesn't mean it's necessarily correct. And, I would be confident with, say, some of the stuff you downloaded from Vital Statistics database that we worked with the last couple of weeks, because I would imagine a lot of that's been vetted. But imagine just someone typing an ICD code incorrectly, changing that from an X to something else. It's wrong. And the other thing that you notice is there's a lot of zip codes that weren't in the state of North Carolina. Well, that's kind of self-defeating, because it was from the North Carolina Vital Statistics database. So I think some of those zip codes were incorrect. And so I would go through some of the metadata to see what it actually represents. Are these people who died in North Carolina, who have lived in North Carolina? Obviously, not a lot of the deaths were in like Chapel Hill or Wake County, because one would think that, all right, the people just died at the hospital. They could have been living anywhere else, which is greatly going to confound the data. So what are those extra zip codes that don't start with like a 2? That's, for North Carolina. What are they even doing there? And those are some interesting questions that I have that I'll let someone else go and kind of deal with. A couple things before I kind of go off here is I posted some announcements here before I get into this here. So I did post some announcements, and so hopefully, and I really look forward. I heard a couple of things that people submitted in support of last week, and maybe this could be the thing that you're just going to build on, a thesis or dissertation or paper or poster presentation or something like that. You develop a thesis, because me giving you a thesis, that's not fun. The only limitation on all of these is your creativity. These days, it's not necessarily data. There's lots of data out there. Now, high quality, precise, or accurate, or whatever data is probably another issue. But Chantel, she went and looked at all this, she just looked at, was it urban, rural versus SNAP benefits, percentage of people, and I had all the data sitting there. It might be from 2021, but it's, 2.5, 3 years old or whatever. And so I've posted that as well, and you can see I posted this. So today we're going to talk about data cleaning. Next week, we're going to look at metadata. So we're going to use couple of Python programming solutions just to access metadata. Previously, incarnations of ArcGIS Pro, I was able to get all 400 metadata elements. That's really hard. And so we're just going to kind of look at some of the main ones. So when we actually access GIS metadata, we can look at basically it's called item description. We're going to be able to access those. And so we're going to put those, we're going to see if those things are complete. And in 2 weeks, I'm going to be out of town at a conference. So up there, I have the fundamentals of machine learning provided by NASA. And so you're just going to take that course. I would just, I'll provide some more guidance on it next week, because some of it really gets into the weeds. And so I would strongly suggest do it. It's got 2 courses up there, one for remote sensing, one for machine learning. I would suggest do one or both of the courses there. Just show me that you did it. And then in 3 weeks, grad students will be taking the final exam. Undergrad students will be done. And the class project will be 12 o'clock noon. So in 3 weeks from tomorrow, we're going to be done. Okay, so hopefully we've got some good idea for projects, posting them. And next week, I'll kind of post the stipulations for the project. I'm pretty sure I have a placeholder in the discussion board for all of that, so we can grade it. And then what I'll be working on is the final exam, which I've already started, as well as a rubric. I have a rubric, but there's going to be a peer review for it as well. And so I'm trying to kind of fall in love with peer reviews again. I used to do peer reviews because a lot of times when we have job interviews and we hire people, we fill out, we pick out, a component or rubric where who are we going to bring back in? And I want to have a peer review component so that we can really get some thoughtful input back to people and really think about what you like. The one reason why I didn't like previously peer review, because everyone's, when I said, oh, which one did you rate the best or the highest quality, they would just put everyone's tied for first. Okay, great. That's great here, but when people, when 20 people apply for our job, are we going to say, well, we like them all? We're just going to give 20 people the job instead of the one, And so I think you kind of being able to make those decisions and let me know what resonates with you, because I'm just the teacher here. I don't want to be the teacher. I really want this to be a collaborative process, and I would really like to see what students look at, what resonates with students, what helps them learn, and whatever and you being able to kind of flip the script in terms of you provide data, you provide links, and you show us something that you learned that was part and parcel to this class here. So I'll speak a little bit more about it next week, but I really look forward to, what you have to do and what you have to highlight and how you can, how you can start to be a leader here. And that's another thing that I really want us to do is you start to be leaders. I'm going to a conference, I'm going to a workshop or meeting on Wednesday, and I had someone come to me and just say, hey, like, I'm not part of the project, but I want to go. I want to go and be part of it and see what y'all doing there. And those are some of the things that I like, partially because I'm already driving there. It's not going to cost me any money, and they're paying for lunch, which is kind of good. But, to see some of the things we're doing, because it's kind of semi-tangential to some of the work we're doing. So those are the things, when I talk about being a leader that I like to see, and those are the things that we look for and pay for and all that other good stuff. So this is what we've got going on here. And then I'll get back into my talk right here because I want us to focus, I do want us to focus on the Python. And the Python is basically, I'm taking the null value checker. I'm just doing a couple of brand new things to a couple of brand new checks here. I'm going to run it, add a little bit of code to it, and then I'm going to let you kind of take off with it and doing it with you. So a couple things about data quality, because a lot of times I just give you stuff and you start working with it, and then a lot of people take it as gospel. And at some point in time, when you work with the military, such as someone, like I used to make maps like these, the answers I don't know aren't going to be acceptable. So the data quality element that we're going to talk about today and the metadata element we're going to talk about next week is going to kind of put a nice tie, a bow and a tie on kind of working with data and big data sources. I thought this was interesting because I remember this, but there's a lot of knowns, but a lot of things that you don't even know about the unknowns. So, things that you don't even think of. And I think he was talking about the war on terrorism or whatever. Fast is fine, but accurate is everything. Because Cameron alluded to the word precision. What's precision? What's accuracy? They're the same thing. What is precision? What's accuracy? What's accurate?
Accuracy is dead on the point. The precision is I like to use like it's consistent.
Consistent, okay, fine.
Consistent.
They sound kind of like the same thing, right? They kind of sound like the same thing, right? So, but accuracy, basically, how correct is it? Basically, when you take an exam, basically, you're just measuring your answer compared to the professor's answer. That's it. And precision is the measuring tool that we use. And so I can measure the width of the room with a laser rangefinder or a yardstick. So what type of tool are you using? Now, what does anyone care? Are they going to ever ask you this on a job? Oh, Chantel, she already knows the answer. All right. And I bring this up because we have a student here who filed for a job at Durham Public Works, and this person still works there to this day. And a lot of times when you fill out a job application, especially when it's technical, they give you supplemental applications. And so, why do you want to take this job? All these other things, but they give you supplemental application that asks you technical questions. So things like list the GIS software that you're proficient in. At this point in time, this was 2018, 2019. And so we were working with the previous version of ArcGIS. It was called ArcMap, ArcCatalog. But look at one of the questions right here. Please explain the difference between data precision and data accuracy. And so him and I worked on this together. And you can see some examples that we have right here. We calculated precision, data accuracy. But these things really exist in the real world. And so we talked about data precision, meaning we're calculating percentages we want to store with more decimal points, kind of like your GPA. Do you just want to round 3.42 down to 3.0 for GPA? No, you don't want to do that. Do we need 3.427? Probably not. 3.42 is probably a good number to, stick with. And so if we've got values, we don't want to store them. If we've calculated percentages that could have decimals, we don't want to store it as a short or a long and just truncate those decimals when we can keep those. That's what we call data granularity. Does everyone remember me talking about that last week with my food desert stuff? Yeah. But data granularity, 'cause a lot of times, data might not be granular, it might be just 4 bits, 4 possible values or 4 1s and 0s that we can have, which doesn't have a lot of granularity. And then we kind of mentioned about data accuracy right here. And so this was a job application. He still has this job 5 years later. He's gotten a couple of promotions right there, but he created the poster over there. And so you can see some of these, some of the jobs here as part of the supplemental application. Why, what in the field, what is your long-term goals? And you can see he wanted to get into online mapping, enterprise databases. This was a student that kind of just came here and was like, I don't know, I moved here from Jersey. My parents live here. I'm gonna take a class here in this GIST stuff and what's it all about. And he took it and he's made a really good career, just bought a house out in Alamance County and, left his parents live down the street or whatever. But, these are some of the long-term goals. If someone asks you, what are your long-term goals? What would you say on, in a job or an interview? Would you say, I just want to work here for a year or two and get the heck out and get like a bigger, better job? No. Even if that's what you want to do. My wife's like this. She likes to kind of like, boop, 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 I'm always looking for something better, but no. You want to build your career. You want to put yourself in management positions. You want to be, leadership positions, all these other things, kind of cultivating and developing things like GIS programming, online mapping that, you're not going to see in your 1,000, 2,000 level classes here. Online mapping, enterprise databases, they're kind of migrating these a lot more to cloud. So instead of storing databases on dedicated servers, dedicated servers that you access the data, now we're just storing everything on cloud, which is going to just have a dedicated URL. So I think these are kind of some good questions here that we have when we talk about precision and accuracy, because you might need to know it on a job interview. One time someone asked, what's the difference between topology and topography? That was another one that we saw. That was a tough one, real tough one here. Okay. So data, accuracy is going to be important here. Going to be important. And if you're ever on one of my committees here, or if I'm ever on your committee, I'm going to be the one that says, where'd you get the data? How do you know it's correct? How long did you get? What period of time? Because if you're just looking at 1 year's worth of data, what's the problem of working with 1 year's worth of data? Small sample. That's what we looked at last week, where we went and calculated gun deaths and normalized them by population. We still didn't have a normal distribution because we still had so many zero values. So if we get a 5-year sample or a 10-year sample or a 15-year sample, we're going to have much more of a normal distribution because we're going to have a lot less zero values. A couple things about data. I thought some of these were kind of interesting, but what we want is information to data to knowledge to facilitate data-driven decision-making. That's the important thing. And some of the things that we do with hubs and analytics and all this other stuff that you might hear about in sports and that bleed to other places. Why do we have analytics? Why do you scan in? Why do you type in your number when you go to Harris Teeter Food Lion? They're collecting information about what you buy. That's all they're doing. And so they can put certain products in certain stores based on you. That's all they're doing. And so there's a big push in data analytics, and we hear about it in sports a lot, and it's bleeding into lots of other directions. And so the use of data. All right, this pitch was a ball. I spent $23 at, whatever, Food Line today on this product, so that someone can put this as part of a database, which probably has millions, hundreds of millions of records, because we're just working with relatively small databases. Voter registration database is about 7 million records. What we were looking at last week is about 120,000 data records. You're probably getting into you got a couple million records over years, and now it's
Filtering.
filtering through, and now it's starting to get really big and bulky and takes a little time to run and export and all that other good stuff. Some of the things I like here, I like here, if you've got bad data, then it's really can't really trust everything. And we'll talk a little bit more about that in a second here, because when we look at how good is your data, first of all, what's the scale? When we work with Vital Statistics database, it's at the zip code level. If I wanted to get gunshot victims or gunshot deaths for 2021 at a finer scale, what am I going to have to do? I want to get it at a better scale. Zip code's not good enough. What am I going to have to do? Contact it's going to take a lot of time. I don't want to do that. I just want to go and download this stuff. That's big enough pain in the neck as it is. And luckily, I've already got lots of data on SNAP benefits, age, race, lots of socioeconomic, demographics, environmental variables at the zip code level that I've gone through and extracted, or probably at some point in time made Chima go through and extract at the zip code scale, or he's doing it at the block group scale at some point in time. The precision or resolution, and so we alluded to this before, so a lot of times we hear the word resolution when we talk about remote sensing, exactness of the measurement or description. And so am I rounding up? Am I rounding down? If I have median household income, am I rounding to the nearest cent? Do you really need to round to the nearest cent? Probably not. And then accuracy, lineage, currency, the documentation. We'll talk about that a lot more next week. The metadata, so how current are the data we're working with? Because the biggest problem we work with is this whole idea of the original sources of the data. When we work with crime data in Durham, and I'm kind of looking here, is anyone in my crime mapping class? I might put Lauren on the spot here in a second. She's joining us online here. One of the things we look at when we start to associate like socioeconomics and other things with just general crime at the county level, I really don't like it. And why? Do you remember why, Lauren?
I'm sorry, did you call me?
Yeah, yes. Do you remember why we don't like mapping stuff? I was talking about the crime mapping stuff we were talking about today. Why don't we like mapping like crime across the entire state? Do you remember?
Well, I think, did you say something about like sometimes the numbers can be skewed, or like if there's too many people in the points, too many
Exactly.
points?
Exactly, yes. And some of the things we were looking at here, and I'll kind of bring this up. If I were to just look at Durham crime for just Durham City, we have a place called the OpenGIS website. Has anyone heard of those here? And basically, this is just a hub. We're creating hubs here. Basically, they're just cloud-based databases, and they have a front-end website. So they look like nice, pretty websites. And it's got this open data here so that I can go look for feature services, Excel files, document links, mapping applications, CSV files, all the data that we just post to the cloud that we can go and download and utilize. Now, a feature service is just basically like a feature class. That's all it is, a feature class. What I like to do is go to my Living Atlas, ArcGIS Online, add it and export it to my computer. But these days, a lot of people work with these. Those are some of the things that you were working with previously. Sometimes they let you export them, sometimes they don't. Sometimes when you run into issues when you start running your joins on those things, and they're sitting somewhere else, and the owners are like, I don't want you running joins on my stuff. And so that's why I like exporting these things out. But one of the issues that we run into just when we start looking at data accuracy, and it's not the actual data's fault, it's not the organization's fault, is that when we look at sheriff's crime and DPD, they're collected, two different organizations collect crime for this county. And when we look at the actual sheriff's crime, these are the attributes used to express it. UCR code, offense underscore description, counts, officer activity, larceny, offense description, date of incident, operation method. Where that I look at this here, I have year stamp, month stamp, report date, charge description. I don't see anything over here called charge description. I don't see anything whatsoever at charge description right here. And so the attributes used to store data in the city versus right on the other side of the city limits are collected by two different organizations using two entirely different reporting standards. And so when I look at the DPD crimes, I see vandalism, aggravated assault, simple assault. Sometimes I see things like towed or abandoned vehicle. Is that a crime? I don't know. I'm just counting them all. I'm not sure if it's crime. A missing person, is that a crime? And so these might be calls for service so that you might need to go through and actually vet out everything that isn't actually a crime, where that these have already queried out the crimes themselves. And so when we go to this open website, we've got sheriff's crimes, incidents, DPD incidents, shooting events, DPD arrests, DPD incidents using, this is called a National Incident-Based Reporting System. Does that ring a bell, Chantel? Okay. What does SRS stand for? I'm not sure. UCR is Uniform Crime Reporting Standard. Is that right? Sounds right. So even when we get data for this same relatively small, it's a medium-sized county, it's difficult for us to get crime rates between city limits and outside of city limits just because of these reporting standards. And imagine trying to do this for entire states. Now, it's probably pretty easy to do for, hey, let's look at all the homicides by county, or let's look at all the shootings by county. And especially with the death data, it's relatively easy to do because those are going to have health outcomes related to a standardized database in the vital statistics database, which is pretty good. And so it's really important to kind of recognize this, because one of the things a lot of times when I start looking at crime data, and more so recently because I'm teaching a crime class, a crime analysis class, is that it's really hard to do this at the kind of multi-county level, because Durham Police Department, they only care about one person. That's Durham Police Department. That's it. They've got to get their function probably with one crime analyst. I don't know how many police officers get this into a GIS, and I'm sure they have got federal reporting standards, state reporting standards that they need to adhere to. And so these are some of the things you think about when we think about data quality. So when you do a project, that's okay here, but you do a thesis or you do a dissertation, how good are your data? We have different standards, because you notice we just looked at crime in Durham County and they had two entirely different standards, which I think is interesting. Now, who's going to tell Durham County how to do their data, and who's going to tell Durham City how to do their data? I don't know either. Now, when I work with the military, we work with something called SDS-FIE, which is Spatial Data Structures for Facilities Infrastructure Environment, which was a uniform data standard, which had the names and the actual attribute that we were going to use. So we didn't call them roads, we didn't call them streets, we didn't call them highways, we call them road underscore centerline, firing underscore points that we used as part of our GIS. Is we loaded it into this big system, a blank database where we basically loaded them in, and then We loaded in just every single feature class that was blank and then took it from our working shape file or whatever we did at the time. So we've got standards. These standards exist for a number of reasons. Next week, we're going to look at a metadata standard that I helped develop for the state of North Carolina. Real fun. That's another thing that'll help you put to sleep, get you to sleep. But I think those things are important. I think those things are really right for research. People like to do the fun, I don't want to say sexy stuff, but the interesting things here. But standard development is really, I think, whether for crime data, because the analysis and the utilization of GIS spatial data with crime, marrying these things together, is still in its relative infancy. And so it's still kind of, to me, still kind of like the wild, wild west when it comes to what are we going to collect? How are we going to collect it? Durham County and Durham City can't even talk to each other. And so me trying to make county level maps of crime is going to look silly. You're going to see discontinuities between when you go into they're either going to go really up or really down based on their reporting standard, UCR versus NIBRS or whatever. And so these standards are really, to me, important. We've got external bodies like Federal Geographic Data Committee, but these are the things you think about when you start working on projects, because who sets public standards? Typically we do, or we help working with these. Well, we have an organization called ISO, International Standards Organization. So I could go to Europe and I could put my ATM card in there and it works. Why does it work? Because they're all the same, right? Everything, so my card understands the strip. And so the ISO standard for that. Anyone ever go to Europe and they have like the wrong, the outlets and things like that? So the outlets, like they're not like this. They're wrong. In Nigeria, what kind of outlets do you have? The other ones or these? Same as these. But in Europe, they have like the big ones and you got to like plug them in and all that stuff. And I had my hair cutter and it like blew up because it didn't have like I cut my hair, so. But it blew up because I guess I didn't have the right thing or something like that. I don't know. It wasn't good, we'll just say. Okay. But these ISO organizations, and when we say these, and you think of something as simple as just your ATM card that you put into a machine, and anywhere in the world it's going to be understood because it understands how thick and wide and deep these ATM cards are going to be, so that we don't go look at some of these differences as well. We've got national standards. We will talk about some state standards next week when it comes to metadata and data collection. And North Carolina is really on the forefront of GIS within the state. There's a thing called North Carolina One Map, and every other year we have a North Carolina GIS conference that I think next year is going to be held over in Raleigh there, because they switch every year. And I really like to have our students have strong representation there. And I think Chima you presented there, right? Chima, like Sarah's presented there. I've taken a number of students over there, and they're really focused on the practice of GIS within the state. What are you doing with transportation? What are you doing with cultural resources? What are you doing working, with the federal agencies there? And it's a really good organization, and that's a good place to kind of get in at the ground floor and meet people there. When we adopt standards, data quality is achieved by the adoption and use of standards, and just make sure you use it. So I'm not going to go, when I worked for the military, I'm not going to use my phone to go out and collect GPS data. I've got a high quality GPS unit over in my office. I need to figure out how to use it, because I think it does connect to my phone, but it uses the GPS signal from that as opposed to my phone. So I'm going to go and collect like military or high quality GPS readings from that, as opposed to something like this, which might be 50 feet off, 100 feet off, or maybe 5 feet off, depending upon the day and other conditions that exist. Federal agencies use FGDC, Federal Geographic Data Committee, which kind of started in the mid-90s. But we've got content standards to store these. Next week, we're going to talk about metadata and extract information from metadata using Python. You will all be doing that this time next week, or a little after next week. So the importance of standards, most important standards, and these are some of the things where you see like railroad gauges, Baltimore fire of, this was 1904, where like the hoses didn't work for different, stations. So, and I think this was talking about 9/11 response, the incompatibilities between GIS data sets, especially when GIS was just coming about, where, I've got a system that doesn't read coverages or shapefiles, but we store ours using that because basically these tragedies or these incidents don't stop right at the, city limits. You're not just driving along and you drive into Durham County and there's a crime there. It's collected using an entirely different standard in 2024. Now, it's probably not Durham City's fault. It's probably not Durham County's fault. It's, I don't want to use the word fault or anything like that, but that's the way they've been doing it. And we're just going to keep doing it until the person who does it dies and they get someone new, or they start to speak to each other, or however those things work. So we have accuracy right here. And basically accuracy, how accurate is data? And today we're going to focus specifically on data completeness and attribute accuracy, but we'll look at some forms of accuracy right here. The quality of data, how good is your data? And I'm going to be the person at your thesis or at your dissertation that says, where'd you get the data? Let's put some really good verbiage in there for your dissertation or your thesis as to where'd you get the data? What'd you do to it? How do we know that it's accurate? Hey, let's just check out some of this documentation to make sure it's okay. Because we run into issues like this all the time. We see something like this. What's wrong with this map here? This is a data accuracy issue here. Okay, this is taken from my phone. What's wrong with it? I'm just driving along and I see this and I'm like, oh, this is wrong. Well, what's wrong with the mileages?
It says 22 minutes, but I don't know.
Barbara's right. It says 22 minutes, about 42 miles. How fast would you have to drive to cover 42 miles in 22 minutes? Yeah, you average, well, this is 2 miles per minute. So you're like 120 miles an hour. Now, why is it like this? Anyone have any ideas why it's like this? What did we talk about at the beginning of class? Speed limit, exactly. And so we had a section of road from those arcs, and a little intern was working on one of those 1.1 million arcs, and instead of typing in speed limit 30, they put a little extra zero in there. So that section of road has a speed limit of what? 300. So what's the time on that? It decreases that time right there. Okay, now I notice it, but someone like my wife's just going to say, 2 minutes to get to me. Oh, I don't know why I'm half an hour late. It said 22 minutes. Hey, you're in the middle of Virginia. Okay, so that's just a data accuracy issue right there. Another one that we've seen is you're just driving along and you see this once in a while and there's no road you're on. And a lot of times I've got iPhones versus Google versus your Androids, they've got their base data is going to be a different source. Some of the other things that we've seen before is that I go to Google Maps versus iPhone, and they're going to give me different travel lengths, different travel times, and different actual routes to go. And we see this manifested in data quality from time to time, whether it's the algorithm or the actual data themselves. I thought this was neat. I was in Atlantic City about a month ago, and you could see a 18-wheel truck drove onto the boardwalk because it was denoted as just follow this, get on to this. And I thought this one was interesting. This is the middle of Oregon, out in La Grande, which is kind of the north. northeast, and a truck driver had to walk 36 miles after their GPS took them up up a mountain. So it took their 18-wheel up there. They got stuck in the snow, and then they had to walk 36 miles, out of the woods to get home. And so when we look at things like horizontal accuracy, and this kind of sums up my our project that we did, and we're going to focus specifically on attribute accuracy in this class, is that we've got Spalding Elementary. If we were to go to NC1 map and download schools, you can see where it lines up. You can see exactly where the point that represents Spalding Elementary lines up. But over here, these are my kids. The one at the top is my kids' high school and my kids' middle school right there where they used to go. And this is the middle school and the high school. So if I were to look at all crimes within a half mile, it's not going to be within half mile of the school. It's going to be within half mile of the points. Now, who's going to go and change all these? Is Cameron going to do it? Some point in time, if you notice, hey, I'm working with this data here, I better change this if I'm doing like county level analysis. Well, they don't, they just probably geocoded these things, and this is where a little geocoder, the XY locator popped it, and I'm going to move on. And then we can see some other examples. This is my house here, and you can see that this is my parcel, this is my imagery, and you can see I own my neighbor's driveway, right? No, something's probably off. Okay, these aren't survey grade right here, and this imagery is probably off because it's taken somewhere.
It's next door to my parents.
Okay, well, that guy wants to buy, he was talking about buying like a little chunk right there so he can put up a fence.
Next door neighbors, on the driveway.
Oh,
They did it every.
You're talking about like the paper, like the research in different NCDOT. I know from my experience now, it's more like a lot of the organizations, the planning organizations and NCDOT pretty much all required to be on the same coordinate system.
yes,
And it's like making sure, regardless of importing data or creating the data, it has to be the same to prevent stuff like this from happening. But you could have imported, a different coordinate plane onto something else.
yes, and
Then it might appear wonky when in reality it will be fine.
yes. Cameron was talking about using the same coordinate system for all the data you're working with your MPO, Metropolitan Planning Organization. And the one thing I don't think people realize when we work with ArcGIS Pro in terms of previous versions of ArcView software that I used in 2002, you had to have everything in the same projection so it would line up with each other. And these days, if you have something in WGS versus state plane, which is measured in feet versus degrees versus meters, ArcGIS Pro is going to auto project it on the fly and just stick it into the same projection, where that we can create feature classes that are all in the same projection. And if you go to data management tools, it allows you, hey, I want to change this from WGS degrees to state plane. We'll run through that process, and probably it takes 30 seconds to convert all of those instead of converting it on the fly, because this is where you see a lot of these, you don't see a lot of these errors, but converting something from degrees on the fly to feet here, you're going to see some error. And if you convert it permanently, it makes it nice and neat. Back in my day, I had to change everything. I had to figure out what the projection was, change it by hand, and then make sure everything in my database was the same exact projection. These days we kind of suffer from that a little bit. Another thing is temporal accuracy. We'll talk a little bit more about this next week, but how old are the data? And if we look at metadata, kind of some raw metadata, I can look at how old the metadata is for a particular file here. So these are Camden County parcels. I can see it's good as of January 1st, 2016. So when someone says, hey, do we need to update the Camden County parcels? Well, it's 8 years old. Yep, we better go and visit those. Now, next week, what we're gonna do is, we're gonna talk about ways to pull information like this into one place, because my whole PhD dissertation was, my boss would ask me, like, we have 100 military installation, which one has the oldest data? Each of those have about 100 data layers, so 100 times 100 is what? A big number, 10,000, 10,000 data layers. I didn't want to go and hand check 10,000 data layers by hand. And so what I would do is I would loop through a database, all the feature classes, and just pull out the metadata. Have you ever looped through a database and looked at all the feature classes? Yeah, I see people nodding their head. Yes, we have, right? We have. I think so, right? We like counted the number of features and all that other stuff. Didn't we write a program where you compared the number of features in one to the other? So we can pull the number of features, but we're going to pull out more specific information, specifically from something called the metadata object, as opposed to, we can look at a tree view of something that I've done in the past. But when we look at temporal accuracy, this is what we call a DRG, digital raster graphic. If you're old like me, you might have looked at paper maps like these from the USGS and looked at these in class. Now look at North Carolina Central University. We're sitting right here at Hillside High School. So Hillside, the one down Fayetteville Street, used to sit right here. And then here's some other things here. Here's some other images from campus. We've got the nice student center over here right now. The three little buildings on George Street are long gone. One of them used to house this place called Summer Ventures. And the reason why I might care about something like this is that I go and download or utilize or buy data from a place called InfoUSA. It's called Data Axle now. And I say, let me look at the food environment. Let me look at the distance to the nearest supermarket or whatever. And so this is and I show up at the place and this is the supermarket. Well, it's really not a supermarket. It's not even open, it's closed. And so if I'm just working with this raw data that I've never checked or QA/QC'd in any way, shape, and form, I would say the people who live in this area, if I'm just working with the data, are not food needy, but in reality, they're really food needy. A couple of the other things I'll measure, and this is what we're going to focus on specifically today. Attribute accuracy. So when I click on something, click on a feature, are all of these correct? Okay, did someone accidentally type in a speed limit of 300 versus 30? Who's going to know that? I don't know. Like, who's going to go through all 1 million of those records? I'm not. That's why they invented grad students. I'm not doing that. I already did that. So who's going to check to make sure these things are correct? And unfortunately, these issues with data quality kind of only rear their ugly heads when there's a problem. When we start, when someone at the state level says, hey, I want to map all the the crime in Durham, and we can't find we can find all the gang crimes outside of Durham City, but not inside of Durham City because they didn't want to collect it. Or they didn't collect it. Or they call domestic violence something else. And so we've got to mash all those things up like we did with some of that vital statistics database from older areas. And so when we look at attributes, is this thing really correct? Is this thing really a Pinkley, Wiggly, and Wilson with this sales volume right here? Because when I download this stuff, I assume it's correct. But even when I work with like data that I purchase, it's not always correct. And that gets tricky. That gets tricky and tough. Now, the solution isn't to go and create all of your own data. Because, think about, collecting store data, how much it takes. And Benjamin sits over here and he's joining us online. He's out collecting data about the prices of staples like bananas and milk and eggs from stores nearby and mapping those and graphing those. That's hard. Going out and collecting, what we call primary data. You're not downloading it, you're not utilizing it, you're not doing anything. You're out collecting it yourself. And so those of you who do that, I think probably have a little bit more of an appreciation and understanding for all the time, effort, energy it takes to go and collect this imagery. And kind of like our project, it was like a summer project to do this. You know, it paid like 5 students, it paid 4 students, and me a little bit. It was a pretty neat project. It funded someone for a year. And then the last thing I mentioned is precision, meaning are we just going to round stuff up, or are we going to keep this number? Okay, less granularity, more granularity. So if I can calculate drive time in minutes, you know, with this type of precision, I'm going to keep it because I can do correlation plots and scatter plots and things like that a lot better than just truncating. Even though I say the word 10 minutes, 11 minutes, you know, if my wife says, how far away are you? I'm not going to say 10 minutes and 13 seconds. You know, I'm just going to say 10 minutes, but it would be really nice to have that original number there, especially if it's been calculated for. Because it's really difficult to collect. And then things like GPAs and all that other good stuff here too as well. All right, so what we're going to do is we're going to open up the exercise, exercise 8. We're going to start working on that. And I'm going to talk about it, explain it a little, and then we'll kind of get started on it here. So I'll give everyone probably about 2 or 3 minutes. I'm going to go grab a quick drink real quick to open up. It is called data cleaning. But when we download everything, I'm just going to go to my downloads. So we're going to go and download it. I'm trying to find the right place here. So we're going to click on exercise number 8. I've got some of the documentation right here. And we're going to download week 10, and then the exercise is going to be something that you'll submit right here. So we're going to download week 10, and when we look at week 10, this is what week 10 looks like. So it's got the presentation, exercise 8. It's got this document called NCDOT root characteristics. We're going to open that here. And then you're going to open up the data cleaning APRX. And you can see the null checker I've got there ready to go. So let's take a couple minutes, open that up so that we get to this point about right here. We're going to open this thing up right here. There's a lot of ugliness going on here. So I'm going to go grab a quick drink. I'm going to make sure we can open this up, and we have this open. I can tell who's got it open here. What's that?
No. I said something. I'll be right. What did I want to say? Which one is those in museum? Shape one. I'm sure. Oh, okay, I see. That. This the password, the G1, G money.
I did. Yeah, I did.
Are you ready for your test?
I'm still
This is, I'm gonna say something because I think. I'm put a civil
made for it. It's a sheet. Have so many.
Yeah, and to have done that over. I mean, the holidays, you know, still have kids. They.
Not getting a lot of reach.
Because of the reason. Okay, let's just, I don't know. But.
Did you do that?
Okay, so come on.
This Thursday?
I was, sure. It's my home. Like I said, so many chances, I had to miss. And then I still could, you know, and I was like, that
You're doing your
he
job.
can control
People doing it, right?
chapters. Without numbers.
I wasn't expecting this.
Is there gonna be another school?
And without numbers. Now, we have had a commission of notes.
Right, I'm supposed to be on, I'm gonna be around 30. So, you know,
Right, they're numbers, but we can't use them. And so therefore you have to study for it different. Concentration, and, you know, in order to even. Right, so I'm. It's not a promise. I don't understand. Something about red loss. I don't know if I feel. You do, because I'm gonna share it with them.
that's kind of-
So.
What do you want first? It's gotta be something with this class, like really.
Very, yes. And I'll be doing this separate. Yeah, yeah. I'll end up having to come to you begging for another class, so. But I think taking the time. And I'll also, I think I'll be working with someone over at Duke. With the new, I forgot, it starts with an N, a type of grant that he's gonna do. And he needs one to work in like data science. But I really wanna understand the guy as like the benefits and the.
Okay.
Me. I don't know about that.
I hope so. That's what we all want. Okay. So this is what we're looking at right here. I'm gonna probably take a little bit to kind of explain what we got going on here, because in the left, we've got our table of contents here. And these are some of the data that I've downloaded. A lot of times when you go and work with data or work with a certain topic, and I think I'm just as guilty of it as anyone else is, I just go and start downloading stuff and clicking and pointing and really not looking at anything here. And so what I have here, I downloaded this from the NCDOT. This is highway exits. Now, as you can imagine, highway exits, it's going to be the highway exits. And if you opened them up, they would tell you, I don't know what that means, but it's exit name, measure. I don't know what all this stuff is, but I see 2,500 highway exits. Okay. Next, all the way at the bottom, I have NC route characteristics. And if I clicked on that tab, you would see there's almost 1.8 million route characteristics. Now, these are different than routes. These are route characteristics, meaning if I had Fayetteville Street and it changed from a speed limit of 20 to 30, or it went from 3 lanes to 2 lanes, they would be 2 separate segments. And there's 1.8 million of these out there. And so I downloaded that database here. Now, what are all the different route characteristics we can look at? And so if I were to look at the route characteristics and go all the way to the right, from that page, and also as part of exercise number 8 that I added here, these are all the route characteristics. And when I go to these, I think there's like 95 route characteristics. And so the first one is object ID. Object ID, we hopefully know by now what object ID, it's going to be an auto assign that serves as a link between the attribute table and the actual element or map. But highway division, the highway division number for each route segment. There's 14 different highway divisions out there. And so for column number 3, it's got division. It better have a highway division. Maintenance county code, location county code. So where it's located, who it's maintained by. And I would assume most of the people who maintain it are in that same county. Route class, these are the different route classes that we have there. And so you can start to think about, all right, I got null values. I can go and check to see if I know something is an interstate, what's the speed limit of it gonna be? 60, 65, 70? Do we have a speed limit 75 here? No. No speed limit. So you have a good idea as to kind of the speed limit, because I'm thinking about what happens when we go to speed limits and we don't have anything populated. You're gonna have to go and populate those. And you can do those kind of by brute force, meaning let's go through a select by location, but you show up to a boss and say, hey, look at this neat little, speed limit checker that I did. We could do that. Route number, route qualifier. I don't want to go through all of these here, but when I worked with the NCDOT, some of the things that they wanted was AADT. So we have segments of road that have the average annual average daily traffic attached to those. Some of the things that we started looking at with the NCDOT, improvement types, left paved shoulder width, right paved shoulder width. These are some of the things that they wanted to look at to see if it was actually populated, meaning for safety reasons or whatever. There was about 30 of these that they required us to populate. Median type, they always wanted to know, like they were big into the median type. What's the median type? And it was a text, and it gave us notes about though. It gave us notes about those stipulations, median width, NHS, which was important to them. But as you can imagine here, this got really ugly really quickly looking at all these. And so we wrote some neat programming codes to kind of look at these. Now, one of the things we're going to look at is speed limit. So I'm going to do SPE. I need to spell it. And so I can see number 74 is speed limit on page 32. And so let's see what I've got here for speed limit. And this is just one because we look at numbers right here, but this is the posted speed limit. It has to have positive numbers. Data comes from traffic ordinances. The speed limit is 35 within municipalities, and where there is no ordinance, the speed limit is 35 within municipalities and 55 outside municipalities. So I bet there's going to be a lot of null values there, and maybe we could figure out why there are null values. Military bases. And so there are people, there's probably a dozen people over at NCDOT that work with this stuff on a regular basis, and it gets published every quarter. Every quarter. And so when we talk about these route segments where the median changes, where the speed limit changes, we've got a brand new length. And so Fayetteville Street might be, even though it's maybe 6 miles in length from here down to, Route 40, it might have like 20 different segments attached to it. And so these are some of the things that I really implore people to, get some access to and do this. Now, since it's such a pain to run, up here in the middle, I have just the route characteristics for Region 7. So I just exported everything out for Region 7. And so we're just mainly going to work with this for now. And I think this is Guilford County over here, Durham County over here. Where am I? Burlington. Okay. Nope, this is over where I live here. So this is Guilford, Greensboro, Chapel Hill, and what's this? What's the little county north up here? Yancey County, is that right? North of Alamance County. This is a geography class too. So I just extracted out these. And so when I look at the Region 7 characteristics, I only have about 90,000 of those to make it a little bit more manageable. I only have about 90,000. And if I were to go over to speed limit, that's about 2/3 of the way through. You can see Burlington over owner types. I've got some nulls here. In some cases, nulls, are useful. Some cases they might be. I might not be, but if I go to speed limit right here, sort descending, let's see what I got here. I've got some 70s, but you notice I have a whole bunch of nulls. And so about 2/3, 3/4 of the way through, I've got a field here called speed limit. And so I can sort these, but I've got some nulls here because what we're gonna do is get to a point where I wanna replace those nulls with something. What am I gonna replace them with? Well, whatever you want. How are you gonna figure out what to replace it with? It might be dependent upon something else, some other field. And I don't wanna make this too ugly here because what we're gonna do is we're gonna open up the null checker and we're just gonna open up the null checker that you already wrote. Remember that null checker that just counted the number of nulls in a field? And all we're gonna do is just edit that a little bit and change these. Now, one of the problems with this database is I want to see all the different values for speed limit that we have just for this. And I'm going to do it for region 7 just because I don't want to run summarizes and queries on all 1 million records. So I'll just run it on 91,000 records here. So I want to count all the records here. And so what I'm going to do is just right mouse click under speed limit and click on summarize. What does summarize do? What's summarize mean? Don't use the word summarize to define summary. But
Essentially, you pretty much pick out the information that you want to work with.
okay. So when I run this table, what's it going to give me?
Like statistics.
Not statistics, frequencies. It tells me the number of times because under speed limit, look what I could have done. I could run statistics, right? Now, what is that statistics going to do? And is it going to be useful? No, it's going to average up all the speed limits for all of these, count the number of times it's null. I don't really care about that. What I care about is what are all the different speed limits up there? Because what did that big, ugly document say? It's got to be a positive number. Did it tell me all the possible values for speed limits? Positive number. And let's look at these too. So I'm going to click on summarize. I'm going to click on summarize. I really am. Okay. And I'm going to click on region 7 speed limit summary. I'm going to start getting into good habits. Region 7 speed limit summary. So when I teach this class again, I can kind of come back to here. And all I'm going to do is just count the number of times it appears. I'll just leave this default the same. I don't really particularly care about that first thing right there. All right, so speed limit summary. So if I right mouse click, open, what's this tell me? I have a -35 appears what? 14,000 times. 1 out of every 7 is actually a negative. I've got 44,000 nulls. I've got 15.8, 158 20s, 25, 33. 33, you think gonna be a real speed limit? I think someone mistyped or fat fingered it, 30. 45, 50, 55, 60, 65, 70. Okay, cool. So we can go and run these just for the heck of it, for the root characteristics. And I'll show you actually what we did here. Just for the heck of it, we're going to look at all the different speed limits for this here. And I'm going to run it here real quick because I was the one who went and messed up the database myself. So.
Yeah, mine is, it's not even summarized.
Oh, because I'm gonna just go to division and first. And I didn't want to do it for the entire database just because these things take it takes a while to count 1.8 million of anything, and I'm adding these up. But what we're gonna do, and what you might wanna do, what's up?
We didn't summarize it. It's giving us an error code.
What's it say?
We're not gonna create output.
Unable to create output. Did anyone else have that error? All right, let's see. Let me join people here. Unable to create output. Whose fault is this? Can't be mine. Oh, yeah. Why? Why can't I create it? Not create output, why? Where are you guys going? You're going to my C drive. You wanna save it to my computer? So, click on output table. Now click on data cleaning right there. Open. Now. Yeah. Click on the folder right there. Let's forget about the sum of the speed limits and all that other fun, you know, because it needs a calculation. All right, one of the things, I'll come back here. Couple people ran into some errors when it ran it, if they clicked OK, because it was trying to store it to like C, EISC 305320. That's sitting on my computer there. Now, it was probably something I didn't do right, but when you run this, and I'm gonna do it for the NC characteristics here. When you run this, right mouse click, summarize, just to check yourself. Excuse me. Click on data cleaning and make sure you're locating the right folder there. Now for the entire state, let's see what we got here. -60, -35, -25, 33. Oh, yuck. Someone really messed up here. This is really bad. What are we gonna do? Now, you can go find and replace, select by location. You can do all that other stuff. But we're gonna just use what we had with our null value checker and do this again. I'm kind of implore everyone to, just think, now are we gonna have to write this from scratch? No, we already did a null value checker. And so those programs that if you're really bored, you can go and look at that we wrote for the NCDOT. I didn't write those from scratch. I did some type of model builder and then I added my own custom code to this. And this is gonna be the same way for this thing here. And so we're gonna work with this one right here because this is the NC road characteristics for Route 7. And I wanna kind of look at all scenarios here. For this one, I only see a -35, but eventually, what are we looking at here? Oh, we see a -35, we see a 33. And I bet you the 33 is probably gonna be a 30, right? So wherever we see a 33, we're gonna make it a 30. Wherever we see a -35, we're probably gonna make it a 35. Do you think we can write custom code that does that? And then eventually what we'll do is we'll get to every situation that does that. Now, we're going to look at the code that I created because what I did was I already started editing it. And so we're going to go to View, Catalog pane, And then over in toolboxes, you'll see null checker. Do you see that null checker over there? So we want to go to view, catalog pane, toolboxes, data cleaning, null checker. All right. Does everyone see that there? All right, Daisy's nodding her head. I thought I saw Andy kind of nodding a little bit there. Good, okay. And we're gonna open this thing up. When we open it up, what's this look like? And even if I were to click on it, view, catalog, null checker, what do I have? Come on. This tool's taking, I need a new computer now. All right, what does it need? What are the input parameters? The feature class and a field. What do you think the field is that we're gonna pick? Speed limit. For homework, what do you think you're gonna, hey, let's pick another field that based on the stipulations. Maybe it's gonna be highway division or something, and you're gonna go and check and edit it or do whatever you wanna do. So what we're gonna do here is we're gonna go pick a feature class and a field. And that field's gonna be speed limit, and you're gonna have the flexibility to change whatever you want. Now, I'm gonna go back here. And I'm gonna go to my right mouse click and my edit. Now, when my edit opens up, I've got my what is this? Visual Code Editor? Visual Code Editor. Does anyone use this Visual Code Editor here? Chima does. I like it. I personally like it. I'm starting to like it a lot more than the IDLE that comes with integrated development learning environment that comes with your traditional ArcGIS Pro install. But I like this a little bit better. But what do we have here? We did this for the null value checker. Look what I started to do right here. Because remember, if row 0 is none, that's just a fancy way of saying if it's null, what do? I'm just gonna say, hey, record number blank is null, and I'm gonna add up all the nulls. We did this for homework. You know, you picked out a database or picked out a feature class. You picked out a field and you just ran the number of times it was null. And did you calculate like the percentage of nulls and all that other good stuff? You gave me some nice little descriptive statistics for me. Now look what I have here. Now what's this row 0 mean? That's just from the computer code here. But we've already written all this. Okay, we've already written all this. Okay, we input just one field. Now I can input lots of fields. How many fields did the original input parameter ask for? Just one. I could ask for multiple fields. I can run like 5 fields at the same time. We'll let Chima do that on his own and whatever. You know, that's tough. You know, it's probably easier, but I don't want to do that. I'm pretty simple with all this stuff. Okay, and those of you who are really good programmers would probably get the wheels spinning, could probably do some really interesting things, really good things. All right, so what am I adding new here? I just added a couple lines of code here. I added about 5 different commands right here. And those of you joining us online, we're looking right here. Those of you joining us online, it says if row 0, and basically that's the first field. There's only one field that we've brought in. And a lot of times when we talk about arrays or collection of objects, we don't start with object 1. What do we start with? Object number 0. Starts with object number 0. Okay? And so the first field, which is object 0, which is speed limit or whatever. In this case, it's going to be speed limit. It says is not none. What does that mean? If something is not none, what's it mean? It has a value, and the same exact row is less than 0. So what are we checking for? If anything's, exactly, it's checking for negative. Exactly. So we're looking for all that negative garbage. And what do we have to say? Hey, record number, whatever we have is less than 0, because we're just going in sequential order. We're just starting with the first object ID and down the last object ID. Now imagine running this with all like 1 million records. Imagine how big of a record log that you're gonna get. That would be big. And so this project that we did with NCDOT, what we did all the way up at the top, we opened up an external file that just said, hey, let's open up a CSV file. Instead of writing it to my ArcPy add message, we're just gonna add it to a text file or a CSV file and just say, record number 723,000 is less than 0. Record number 722,103 is less than 0. So that DOT can go back later and say, all right, these are all my nulls, or these are all my less than 0. This is all my junk right here. Because at the end of the day, the original database is sitting on ncdot.gov. All this stuff I'm working with here, it's all great and I can edit things, but it does nothing if the people who have it don't change it. And so I just add a message, which is add a message that says, all right, record number, whatever string count we're at right there, count, because all we're doing is just going through the entire database and we're going through 90,000 times and checking it, is less than 0. Count LT0 plus equals 1. All that means is I'm going to also count the nulls, and I'm also going to count the less than zeros, because we already did the null counter. So we're just adding to that null checker. And I think I got a little lazy, and since I knew that it already worked, so I just copied the same exact code and edited it. And this is where I implore people to work smarter instead of working harder. I'm not going to write the whole new database again. I'm going to use the same program that I knew worked, sit in front of all you, and just start editing it. And I'm pretty, this thing runs too. Okay. And what am I going to say? Row 0 equals 35. Do I have to make it 35? No. If I really wanted to, I can make it whatever. I can make it -1 times row 0, right? I'm just going to switch, basically negate it. And so I could do that. But I just went through my original stuff and I said, hey, everything that's 35, I'll make it 35. Anything with a negative is 30, even if it's -60 or -80. Is that correct? Not necessarily, but just for the heck of it. And the new thing that I added here is cursor.update row. And this is a little bit different because previously when we did null value checker, we just kind of went and checked them and didn't do anything. Now what are we doing here? We're actually going to update the value. Because what does this equal to sign mean? What's that? Takes on the value. So this row, because here previously we were just checking to see if it's equal to, if it's not. Now this cursor, it's basically, we call it a cell, but we're at row 27 under the field speed limit. It's going to take on the value of 35, and while we're there, we're going to update it. We're going to update it. That's pretty cool. Now, thinking big picture here, if we have null values, and I don't want to get too much into the weeds here because I want to run this and maybe let people start thinking about some of these things here. But hey, if we have, what are some things right here that we can put that says, hey, if it's null, what are some things that we can check? Because when we go back to our ArcGIS Pro, I had 44,000 out of the 90,000 that were null values. What do you want to populate in those 44,000 values? What are things that you want to check? We could check some of the other fields. We can check some of the other fields. And so we can, I need to, so now we can say, all right, if row equals none, and then here, if row, and then we have to reference it using a field name. and say, hey, if the highway class is equal to 1, then speed limit is going to be equal to 30. If road class is equal to 2, speed limit's going to be equal to 40, 50, 60, 70, or whatever. We can refer to some of these. Now, this rho sub 0, that might be a. Can I just put that in with single quotes? I'm asking Shima. I can? No. How am I going to have to reference that? Or we can think about that later, so. Meaning, hey, I've got to go back to this other field and check. It was a field that I didn't call up. Because my thought, what's that, search cursor? Well, what I would want to do here, I would want to just go row. And so. All right, I can't do that though, I don't think. You're saying no?
You can do this, you
Oh.
can do this.
Okay.
Yeah.
And so what I can do here, I think, we could play with this later here, I'll let you do it, is that, all right, if it's none, and then if row class. What can I do here? If row class is equal to 1, I'm gonna just say, all right, speed limit is equal to 65. Now, why did I indent it? So it's indented because now this is gonna belong to, the only way this is gonna run is that if the condition, this condition, which is null, is true. Because down here, if I'm running this, they're not null. But as I said, is not none. So I could throw a bunch of else if statements in there, but I want to kind of put this sequentially right here. And now, if I've got a null here, it's going to count the number of nulls and it's checks to equal 1. And I'm going to say if row, using the reference for the field route class is equal to 1, then this new row is going to be equal to 65. Don't quote me on this. I'm not sure if this is going to run. I'm laughing too here. It seems too easy. It seems too easy for me to run this. Now, let's forget about this here, and I'm going to comment this out because I want to actually just run this. Because I actually want to see if it's right. All right, so let's keep everything else right here. Let's run it, because what we're also doing here is we're doing the total count, null count less than 0. We're going to write a little Python code that runs this for us. Okay, and I commented everything out. All right, let's run this thing, make sure it works. I got my catalog, null checker. What feature class am I going to work on? I'm just going to work with the route characteristics for region 7. And my field, I'm just going to go down to my speed limit. All right, something's running, good. Now, I added, why is it taking so long to run? Uh-oh. Variable row 36. I think I added something or subtracted something here. Okay. Does this work for anyone? Did you get the same exact error? Okay. Cannot acquire a lock. Few details, okay. Line 36. Beginning of loop through database. The variable row is actually a row record and not a number. I had this running before, so let's get this to work here. All right. Did everyone get the same error? What did it say?
Tool has failed to open.
All right, let's try that. Okay. Come on. Let me circumvent this thing and then I'm just gonna give the homework here and we'll go. All right, so we've got it to right here, frequency, all this good stuff here. And while I'm here, I'm gonna download it fresh in case I messed something up on it. Cause I don't like the cannot get a lock on it. That gets a little,
My notes check over.
it checked.
Yeah.
Whatever Chantel did, just do what she did and good night. All right, ran for you, right? Look all the way at the bottom. Did it everything run for you? Because mine just ran too. And so it can't be. No, so I can see record 21's less than 0. I got a bunch of nulls. And if I go all the way to the bottom here, I had total count equals 9595. Does that ring a bell? Yes. Does the null count 44,132 ring a bell? Yes. Less than 0, 14,429 ring a bell? Yes. Okay, good. Now, when I go back to the region 7 characteristics, and this is the big thing we want to look at here, when I go all the way to the left, or about 2/3 of the way to the left, and I go to speed limit. Thank you to Chantel for reinforcing it. Where's the field for speed limit? Here it is. I'm going to do sort ascending. I got a bunch of nulls here. This time I'm going to run summarize. Now when I open it up again, Where are the negative numbers? They're all gone, aren't they? What did they turn into? That 14,229 went from the negative to the positive. Now, what are other things that we need to correct? 33. If speed limit's equal to 33, what are we gonna make it? 30 or 35. I said 30, why? Because there's no 30-mile speed limit sitting there. And so now we can custom create all of these here. Okay. But this time, this is different than the null value checker because we're the negative. What was the one command that got rid of all those negatives? Update cursor. Exactly. We updated that cursor. And a cursor is just a little, we know what a cursor is, and all it's going to do is just start at this field, go to the next one, go to the next one, go to the next one, go to the next one. And what we had to do is just output messages. You can output messages to a text file. You can output messages to anything else. And next week, I'm going to show some of the stuff I've done in the past because ArcGIS Pro is getting a little bit more restrictive in terms of types of things you can and can't do with metadata, with external files. And also, I just didn't really have the time to go through everything and do it here. But now we can run a check if it's equal to 33. You literally need 2 lines of code to do it. If it's equal to 33, set it to 30, update cursor. And to be honest with you, once you run anything that changes it, how many times do you have to write update cursor? Just once. That's all you need to do. If you know that you're going to be editing something, under all those editable commands, you just update the cursor there. So I'm kind of getting to an end here. But I just want to show exactly what we did and why, and kind of give a charge for the homework. So you can see exactly what we did. So now I have this command here. We can play with these where that, hey, I want to go reassign null values. The reason why a lot of these are null values is because they're in like private neighborhoods. You know, that pay HOA fees and all that other stuff that the state doesn't necessarily maintain. You know, I used to live at a condo, so they didn't go and plow and do all that other stuff. And it was a quote unquote road, but it was privately maintained by someone else that your HOA fees took care of. What's the speed limit on those? 5 or 8? I've seen speed limit 8 before. I guess so people will notice, or 10 or whatever it's going to be. Okay. And so if you want to go through and do this, that would be great. The one thing I would like people to do, and when we look at week 10 right here and look at the exercises, I've got a neat exercise on managing data quality reviewer. You should have it, but there's a neat Esri exercise on managing data quality. Because I think a lot of people kind of just take it for granted. But in this exercise, what we did was just write an exercise that goes and updates a feature class to clean the data based on one of the attributes. Okay, that's all you're going to do. 4 NC route characteristics. Now, you test it on region 7, because if you don't want to figure out where within those 1.8 million records you've messed up. So just play with a subset of those. Export out the Durham County stuff. Because for speed limits, you saw I put in a whole bunch I actually tried to put in like decimal points, but it didn't let me because it's stored as an integer. But I threw in some negatives, I threw in some weird values, and the null stayed. So maybe if you've got some rules to change those nulls. So for this exercise, go through and change one of those characters. Write a checker or a data cleaner that changes one of those attributes. If you want to stay with speed limit, stay with speed limit. If you want to look at functional class, hey, we already know functional class right here. Go through and make sure every single value. This is what we call a domain table. That means that these are the only passable values that route class can be. Could be 1, 2, 3, 4, 5, 6, 7, 80, or 81. That's it. Nothing more, nothing less. Okay. So we can do that. And like route class or whatever. So if you want to write a checker that just does that, and
How do we assign those speed limits based on the route class?
well, you wouldn't do a speed limit checker, you would do a route class checker. Meaning, all right, speed limit checker, you can take it above and beyond, like, all right, I'm gonna go back and check the route class or check the functional class or whatever to go back and forth. But for this assignment, you only need to work with one feature class. Yeah, and you can check. Now, if you want to go back and forth with the speed limit and say, hey, I want to go back, I got no values for speed limit, I want to go and check on this attribute that's going to give me an indication of what it'll be, that's fine. Or if you just see something that's null and you're going to say, you know what, if I see a null, it's going to be a speed limit 35, and that's what I'm going to go with. Okay, but if you're doing this 40 hours a week instead of sitting down here for 5 or 6 hours on a Monday afternoon trying, no, I know people don't do it on Monday afternoon, but if you're going to sit here, you know, spend a week or spend a few hours kind of working on this to do this, it's going to be a little bit different. Where, you know, you're working for the DOT, you're going to have to go through all the checks and functional classes, make sure you're referencing everything and doing a good job on that. So, all right, I'm about done here. Okay, I think I've given us enough work to do. Make sure you refer to the resources we've got there. Do you have a question, Barbara?
Yeah, but it's just that my geographic tool wasn't working.
Okay, I'll see you here in a second here and we can work on that. But I think we're at a good stopping place here. You know, once again, like last week, I implore people to be creative. You know, you can go through and do what I just did and you'll get your 10 out of 10 and all that other good stuff, but maybe do something that kind of expands your skill set a little bit. Maybe reference other files. Because at some point in time, we've got people who sat in this room right here who work over at the NCDOT. Roderick, he's one of them. Another one's name is Nelson. And Mike Wallace, who made that poster right above Barbara right there, he works over at EPA. Like, they are deep in the weeds doing this stuff here. And I think you increasing your Python skills, just very basic Python skills, because you might have to do this at some point in time and you're going to say, I got a Python, we did this, we checked the speed limit, but I want to just go check something else. It's really, really easy to do. We did this, and this was another project that I did back in the day. So I'm never really writing anything original too much. All right, that's enough of me talking here. I think I've given us a good charge for next week, where we're going to hit metadata and kind of be the last time we meet face to face. So anyone for GERS who's presenting at GERS, I will not be here tomorrow. I will not be here Wednesday. I'll be on campus Thursday and then Friday afternoon to print out posters. And then make sure you give me PDF versions of them. Okay, there's a plotter over there in the graduate student lounge. So if you need to print it out at Friday afternoon at 5 o'clock when I'm home watching my kids, then that's on you. You know what I mean? And I think it's really good practice for people to learn to like do these things yourself, because I'm not a printer expert. I just plug it in, follow the directions, and do it. You know, I sometimes get frustrated when like other faculty like send me down to do all their print stuff, and like I'm not your print person. You know, you can follow directions just as easily as I can. But I don't want to sound like your parents when you didn't wash the dishes and leaving everything laying out and clothes and laundry and all that other good stuff, because I'm starting to sound like that, aren't I? So,
You never do that.
what's that?
Never do that.
No, I know, I never did. Oh man, my mom, oh man, all right, nice lady, but she'd get worked up about stuff. We'll leave it at that. So everyone have a great week and look forward to what you have to do. You know, your creativity, your imagination is the only limitation that we have here. So I look forward to what you have to do, and We'll see you all next week. Yep. All right, let me get out of this.